Hi everyone, in this video I'll continue working with the cowl. I'll also install a dashboard and a lot of things on a trifle, and we'll also try to ride. I'll start with the cowl. I removed a forward cowl casing for a while to completely weld all joints of a middle part. Before welding I'd make fastenings to the frame for it, as while the adjustment it was welded to the frame. I want to make it removable so it'd be possible to paint a frame easily. It's time for a full welding of the cowl. I still cannot buy a cylinder for a semi-automatic device, and I had to weld a thin metal with electrodes. I have some experience in it. It didn't cause me big problems. After the welding I smoothed out all welding seams with a grinding wheel. I put away the racks so they didn't interfere with welding operations and adjustment of a forward casing. We need to make 2 more fastenings for it on each side. For this purpose I cut off 2 details from a slab and welded them to the frame so they were hidden behind the casing. I drilled the casing with a slab and pulled together with a bolt. After a leveling I welded thoroughly the joints of the forward casing and smoothed out seams with the grinding machine. All welding roughnesses will be puttied with automobile putty. I degreased all places where will lie a putty with a solvent. I took the usual basic putty, added the hardener and mixed them. I have no 2-component soil, and I'll apply putty upon the metal at once. There's nothing terrible, as it's just a buggy, not Mercedes. The metal is grounded in order that it wouldn't rust under the putty. I will apply the putty several times, as it's never impossible to achieve a plain surface without craters at once. The putty hardened approximately for half an hour, and I began to sand it with a renovator. It appeared to be not a fast process, and I moved to an emery paper and a bar. It is a very dusty work, and it's better to work in respirator. I made 3 laps of putty and more or less adjusted the surface till necessary proportions. I removed dust from the surface and applied white priming on the putty. In the end I had more than a half of priming tin and decided to cover the whole cowl with it. All the same it should be done before the coloring. At first I applied a thin layer of priming. After a partial drying I applied the second layer. So far I finished the work with the cowl and proceeded to the dashboard installation. I removed the steering wheel and made a template from paper for it. I transferred it on the metal and cut out along the line with a cutter wheel. I tried on a blank to the frame and made fastening for it in the form of a crossbar from the section. I got into the cabin and tested the height of the dashboard and distance till legs. If the legs will abut into the panel, then they will be hit by it on the roughnesses. The distance suited me, and I left everything as it was. The crossbar prevents the adjustment of the vertical wheel position. We need to cut out a part from it under the wheel and to weld it back through a clamp. Thus the wheel adjustment will remain and the wheel won't touch the bases and the panel. I cut out a hole in the panel under the wheel too. The panel will be fastened with self-tapping screws. I got inexpensive pseudo-sports wheel on a flea market and I decided to try it in the project. It was a little bigger than my wheel, and if it would be inconvenient I'd return an old wheel. By the way, after reading the comments I decided to wrap up a self-made wheel in plastic as polymorphous. It can be formed in any way. A new wheel is aluminum and it can't be welded on the fastening coupling, there'd be need an adapter. First I took a metal circle. I used a new wheel as a stencil for marking the holes. I cut off a piece from the pipe and welded it to the metal circle. I drilled a hole with a crown for a nut and welded the coupling with splines to the pipe. I fastened the turned-out adapter to the wheel. I tried the wheel in work. It was working normal at first look. We should try it in process. Now it is possible to integrate sensors into the dashboard. I took an electronic speedometer from UAZ Hunter and checked it at once with the 12-volt accumulator. Further I got into the buggy and began to try on its place on the panel. I chose the most successful place behind the wheel on the right. In other places it was intercepted by hands. I made a hole for it and put a speedometer in it. As you've already understood, I refused from the speedometer cable. Instead of it, I'll link the gearbox and the speedometer of a wire. For this purpose I took a velocity sensor. It successfully approaches the gearbox. There were no terminal shoes on sale, and I just welded wires to the contacts, plus, minus and signal. The whole system will be fed by the 12-volt gel accumulator from the motorcycle. I checked the sensor simply by rotating the wheel. The arrow deflects. It's a good sign. I started the engine with the turned-on second transfer on the box. Everything works so far, but it's still not clear whether the speedometer transfers indications correctly. We need to check a speedometer with GPS. Fortunately, there are many such apps for smartphones. Except the speed, it'd be good to know the engine speed. For this purpose I took digital tachometer. It also counted service meters in the background. It has two wires, a signal one which is reeled up on a high voltage wire of the engine, and the volume one which can be fastened to any bolt on an engine crankcase. I made everything according to the instruction, started the motor for a check. According to the engine sound, the indications on the screen were true. Idling turns were a little overestimated. Most likely the speed governor, which I partially removed squeezing a spring with a wire, was incorrectly adjusted. During the test, an arrow of the speedometer fell and stopped to show the speed. I removed the velocity sensor and found out that the rod broke off and remained in the speedometer drive. Most likely the coaxiality of a sensor rod and an opening in the speedometer drive got broken. I solved the problem by replacement of the velocity sensor with the new one. I installed one more velocity sensor which I already had. It will duplicate the indications of speed on the speedometer. After installation of devices, it was possible to fasten the wheel to a steering column. We need to decide an issue with the gear shifting lever. I bought a standard lever. It turned out to be too long and touched the wheel while switching. I cut off a part from it and welded to the coulisses, having rejected a little to the right. Now the lever has a normal length. and it is convenient to switch transfers with it. Before the ride we need to fix the safety belts. I took 4 Takata belts. I welded one more pipe to the frame for the top straps and fixed a nut D for carbines of belts on it. In order the belts did not fall on the engine, I tied the tails to the top pipe. For 2 lower belts I welded fastenings to the pipe near the floor. I put buggy on the trailer and went out to make tests. The main task was to test the speedometers, how much correctly they could show speed with such box and such size of wheels. And I also wanted to try all transfers on the box and the maximum speed. I didn't even think about measurement from 0 to 100 as it is the traction engine which has only 17 horsepowers. I switched on the app on phone and onboard network. Noticed that the speedometer wasn't calibrated correctly. Further, it would underestimate indications on 4 kilometers somehow. It's good that I duplicated the speedometer with the velocity sensor. I started the engine, belted up, and began to test the indication of sensors. It was terribly inconvenient to hold camera together with the phone and a wheel at the same time. I was pleasantly surprised that I managed to pick up details for speed indication correctly. Speed corresponded to the indication from the satellite. I tried to drive and get used to speed. 60 kilometers felt like 120 kilometers in the ordinary sedan. The tachometer indication wasn't visible. I switched by guess according to the sound. Possibly I could also twist the engine before increasing a transfer. The wheel seemed convenient, but I just wasn't focused on it at that moment. It was still unusual to look at such configuration of devices. While switching to the 4th transfer something went wrong. The engine started scrolling and working open-circuited as though it was disconnected from the box. It turned out that the spline took off. I hope it was indeed so. I had to go back and remove the gearbox. Luckily it wasn't difficult to remove it, and I thought that I'd just grind out a new spline and make tests again, but it didn't work like that. As I made the transitional coupling almost by eye on the bad lathe, it had a backlash on the engine crankshaft axis. Due to this the bolt got broken and a key slot was smashed. It made me upset, but it is difficult to make such project without mistakes. I'll think about it further. Most likely it can be repaired, but I need to grind out a new coupling on the new normal lathe and try again. All this you'll see in the following parts, which are left not so many actually. Thanks everyone for your attention. If you want Buggy to recover and work further again, give your thumbs up and share this video with your friends. Subscribe on the channel if you are not yet. We'll meet in the following video.